Welcome. This time we will take a closer look at driving cycles and discuss what they are used for. A driving cycle describes one or several trips driven by a vehicle, and often it is used to analyze how the powertrain is operating and the resulting fuel consumption. Imagine a vehicle which is driving, and meanwhile the driving is recorded as function of time. At a minimum, the driving cycle is a description of how the speed of the vehicle varies during the trip. This is often sufficient if the road is flat. If that is not the case, the driving cycle must also describe how the road gradient varies. Most of the commonly used driving cycles assume the road to be flat. Note, however, that gradients have a big influence on fuel and energy consumption, as well as on how a hybrid powertrain should be controlled. Now we will show how you can read from a driving cycle what the vehicle is doing step by step. Initially, the vehicle is at standstill. Then it accelerates up to 50 kilometers per hour, keeps that speed for a while, then it accelerates further up to 90 kilometers per hour. It reaches an uphill gradient but keeps the speed, then drives downhill still at constant speed. It continues a short time on a flat road at 90 kilometers per hour, then decelerates to a low speed, and finally comes to a complete stop. Note that the driving cycles most of the time start and stop at 0 kilometers per hour and at the same altitude. If this is the case, the kinetic energy and the potential energy is the same before and after the driving cycle, which means that all the energy to propel the vehicle comes from fuel or from a battery, and not from changes in kinetic energy or potential energy. This is important if the cycle shall be used to compare fuel consumption between different driving situations. Driving cycles can be used for many different purposes. The most noticeable is that they are used to determine the certified fuel consumption, and they are also used for verifying that vehicles can meet emission regulations. Driving cycles are also used during development, for example to select the right size of components or calibrating powertrain controllers. Since driving is different in different environments, there is a need for many different cycles. Often we want a driving cycle which represents normal driving of an average driver, but sometimes it is as important to have a driving cycle showing extreme driving, for example to test that the vehicle can handle some extreme requirements. There is also a need for driving cycles representing different types of roads, like city roads or highways, and different traffic flow, like congested traffic or free-flowing traffic. Sometimes the driving cycles are created by measuring when a real vehicle is driving, but they can also be designed to represent a theoretical driving situation, for example to test a specific vehicle requirement. A third way to create long driving cycles is to generate them mathematically from statistical models. This can, for example, be useful when analyzing lifetime durability of components. The driving cycle always includes vehicle speed and sometimes also road gradient, but they may include also other factors that can influence the powertrain. This could, for example, be air temperature, road surface, and when electric vehicles can charge. As this discussion shows, there is not one driving cycle which is always the right one, but rather there are an infinite number of possible driving cycles, and it is important to select the right one for each analysis. The often discussed deviation between advertised and real-life fuel consumption is an example of this, and is caused partly by the certification cycle not being a good representation of normal driving. The driving cycle can be used to simulate the vehicle and powertrain. To do that, we use the driving cycle as input to the vehicle model. It is clear that we can connect the vehicle speed and gradient to the input of the vehicle model. But what about acceleration? Why is that not in the driving cycle when the vehicle model needs it as an input? Since the vehicle model only can base its calculations on information in one single time instant, It needs the acceleration to fully describe the situation. However, the acceleration information is available also in the driving cycle, since a time series of speed values also define the acceleration. The acceleration is simply calculated as the time derivative of the speed. This is the QSS model for the driving cycle. It outputs vehicle speed, acceleration, and road inclination angle, if the driving cycle includes that. Besides that, the driving cycle can also output a gear number I. This is used mostly in certification cycles and then defines how the gear of a vehicle with manual gearbox should be shifted during the cycle. Most cycles does not output gear number. In this driving cycle model, we also output the driven distance from the start of the cycle, x tot, which is simply the integral of the speed values. This distance value is used, for example, when calculating the fuel consumption per 100 km at the end of the driving cycle. In the parameter dialog window, it is possible to select from a number of different driving cycles. The step size can also be changed, but keep it at 1 second in your simulations. To summarize, driving cycles are time series of speed and gradient. Sometimes they also include some other factors. They describe one or many trips and are of varying length. Different types of investigations require different driving cycles. Therefore, it's not possible to have one standard cycle for all purposes. There exist an infinite number of possible driving cycles, as there are infinite numbers of possible types of road environments and traffic situations to describe. Now you can test what you have learned about driving cycles.